Okay, so this is problem 28.4 from homework 7, and they've given us this figure here, and for part A, they want us to calculate the magnitude of the current in the 25 ohm resistor. So, to calculate the current through this circuit, we're just going to want to use Kirchhoff's loop law. So, Kirchhoff's loop law just states that the change in potential difference across or around a loop in a circuit is going to be equal to 0. So all the potential differences are going to equal 0 because the current flowing in is equal to the current flowing out. So this is all just going to equal the same current. So we know we're going to use that, and then in order to calculate those potential differences, we're going to use Ohm's law, which is just the change in potential difference is equal to the current times the resistance. So first, to use Kirchhoff's loop law, we just have to assign or draw the current and basically assign a direction. So I did the direction going counterclockwise because since we have a higher voltage over here, it's going to decrease across the resistor and go to a lower voltage. So I know that the current's going to be going in that direction. So starting off, going around the circle, we have our 18-volt battery, and then we're going to subtract the voltage or the potential difference across the resistor because we know we're going to decrease in resistance or decrease in voltage across the resistor. So subtract that IR, or I times R, and then we're going from positive to negative across this battery, so we're also going to subtract the voltage of that battery. So subtract the 9 volts, and then all that will equal 0. So we just plug in our resistance there to solve for I, and then we end up with I is equal to 0.36 amps. So the current across this resistor is equal to 0.36 amps. And then for part B, they want us to determine what direction the current actually flows. So since we got a positive number here, we know that we were correct in our direction of flow. If this was negative, then we would know that the current's flowing in the opposite direction. So for part B, the current flows from right to left through the resistor. And yeah, I guess the tricky thing to look out for on this one is just check your signs and make sure you know which way your current is flowing, and make sure you're doing the correct signs when you're doing your calculation. And yeah, this all ties into chapter 28, specifically with Kirchhoff's laws and basic circuits.